Good day, everyone. Now we will do a demo on how to make a compliant route and voyage plan in 30 minutes using autorouting. The autorouting module and NavStation can help navigators plan smarter voyages by quickly generating safe and optimized route suggestions, reducing manual route building time, and supporting better routing decisions. Autorouting can create routes between ports or between any two selected chart positions. Autorouting will use shortest distance routing in open waters and suggested sailing paths in confined waters, taking into account routing information such as traffic separation schemes, recommended routes, and other sea traffic-related chart data. During the session, we will use autorouting to create a coastal route, then review and refine the generated route, adjust waypoints and route parameters, and then add the key voyage planning information required for a clear and practical passage plan. We will also show how the blockers can be used to influence the route calculation. Compare alternatives and avoid selected passages where required. But most importantly, we will remember that autorouting provides a suggested starting point. The final route must always be reviewed, adjusted, safety-checked, and validated by the navigator before further use. Now let us move into NavStation and start by opening the autorouting panel. The main working area within the module is the Routing tab. Here we define departure and destination and then calculate the suggested route. The easiest method is to select the departure and destination from the pre-installed port database. I can type either the port name and select that, or we can type the UN low code. As you can see, NavStation offers the matching port once you start typing a name. This reduces manual entry and avoids typing coordinates when a known port is available. But we are not limited to just ports. We can also define any chart position as departure or destination. For example, by right-clicking in the chart, I can select the Auto Route from Here option, and it will pick this position as the departure position. If you select Auto Route to Here, this position is then picked as the destination position. This is a very useful option when the route starts or ends at an anchorage, a pilot boarding position, a berth approach area, or any position that is not selected directly from the port database. We also have the option of entering the coordinates directly. And we can also select the own ship position when the AIS feed is connected to use it as the departure or destination position. The Go-To buttons in the left panel quickly move the chart view to the selected departure or the destination position. If the ports or the positions has been entered in the wrong order, we can quickly swap them. No need to start over again. Now, once the departure and destinations are defined, the Calculate button becomes active. We can now calculate the route, and NavStation will generate a suggested route. Let me quickly give you an example. For the first route, I will create a longer ocean passage from Dampier, Australia to Tianjin in China. This is a route which is commonly used by capesizes while carrying iron ore. This is a good example because the route may pass through several constrained or commonly used sea passages. So it's a good demonstration of how blockers can influence the suggested route. So let's press Calculate. You can see the first route suggestion has been generated. Open the menu and go to the route overview. The route is displayed on the chart view. Now, please note that this route is not the final navigational route. It is a route suggestion that gives the navigator a strong starting point. It still needs review, safety validation, waypoint adjustment, and vessel-specific validation. Let's quickly review this route and see if this route can be used by a capesizer. Let's go down to the level of the departure port, which is Dampier. We can see it is using the deep water channel coming out, using the fairway. Here we see the vessel is using a last strait as the depth is available. But for capesizes, the commonly used strait on this route is Lombok Strait. Moving on, we see that the vessel is going via Makassar Strait, then via Sibutu Passage. It then takes the Koyo West Pass, going east of Taiwan, then into the Bohai, using the South Bohai Strait. Here again, generally the preferred strait used by the Capesizer would be the North Bohai Strait. And here is the arrival into Tianjin. Now let's modify this route to our specific requirements by using what we call blockers. Let's get a bird's eye view of the route. All these green dots which you are seeing on the screen are blockers. They are also listed in the left-hand side panel under the Blockers tab. They are defined areas such as straits, traffic separation scheme areas, other passages that the navigator might want the autoroute to avoid. This is useful when comparing route alternatives. We can close a blocker to avoid a certain passage and see how the suggested route changes. In addition to the chart view, all the blockers are also listed on the left-hand side panel. These blockers can be sorted by all, open blockers or closed blockers. As you can see in the current scenario, I have two blockers closed, Siri South and Bab el Mandeb Strait. I can also open or close all blockers at once. If I press open all the blockers open, or I can choose to close all blockers. In addition to that, we can search for specific blockers if we want, for example, Lombok Strait. Another option is to close them from the chart view directly by right-clicking on the blocker itself. And we can open or close from the left-hand side panel by clicking the status icon. Now, based on the review of our route, as we decided, we would like to go through the Lombok Strait and not the Alas Strait. Let's block the Alas. Also, I would like to block the Selat Sep as well, since the shortest route might be through the strait. Further north, I would like the vessel to go through North Bohai Strait. So I'm blocking the South Bohai Strait and the channel. Once I've closed the necessary blockers, let's recalculate the route by pressing the Calculate button again. Now we have two routes available in the left-hand side panel. The newly created route is selected and is marked red. The route which was previously created is blue. Whatever route I select changes color to red. Let's check the new route and see if it meets our specifications. It's now going through the Lombok Strait using the traffic separation scheme. Using Makassar Strait, passing through Sebutu Passage. The route has now corrected as intended. Instead of the South Bohai Strait, it is now using the North Bohai Strait. From there, the approach continues toward Tianjin, which gives us the arrival routing we were aiming for in this example. At this stage, we can work with the route directly from the list. The main options are to save it, delete it, or highlight it on the chart for review. Highlighting helps us compare alternatives and confirm which route we want to keep before moving on. Once we save the preferred route, it is transferred into the passage planning module, where we can continue with detailed editing, safety checks, and validation. Now, let's move to a second example. This time, we will create a shorter coastal route from Lisbon to Gibraltar. For this route, we are not limited to selecting departure and destination from the port database. We can also easily create them from chart positions. That is useful when the voyage starts or ends at a pilot station, an approach position, or another location that is better defined directly on the chart. After reviewing this coastal route, we may decide the suggested lane is not the one we want for the vessel's trading pattern and cargo condition. For a vessel carrying pollutants in bulk, we can close a blocker so the recalculated route uses the correct southbound lane instead when passing Cabo de São Vicente. Once we calculate again, we can compare the old and new routes, select the preferred result, and save that route for the next planning stage. Before calculating, it is worth checking the auto-routing settings because these choices affect how the route is generated. For example, we can minimize distance inside North American emission control areas, and we can also prefer deep water routes where that is appropriate. Some vessel and cargo-related settings are visible here as well, but they are a work in progress, so navigators should still review the results carefully. Autorouting is not only a separate starting point, it is also integrated directly inside the passage planning module. From here, we can create a quick route from Gibraltar to Valencia by entering the waypoints we want to use as the basis for planning. That makes it easy to move from route generation into the full passage planning workflow without leaving the module. Before adjusting route parameters in detail, the first priority is to complete the one-time configuration properly. This saves time later and gives more consistent results. This setup includes chart portrayal and chart object settings to ensure that the chart display is properly visualized. Vessel particulars and vessel dimensions must be adequately entered, as these are used in various calculations within the passage planning software. The setup of route and passage planning parameters in accordance with company SMS procedures is done in the default values table. NavStation categorizes the navigable waters into 3 main passage types: ocean, coastal, and pilotage, fairway, and channel. These can be customized in accordance with your company's SMS procedures. The default values include cross-track distances, turning radius, under-keel clearance requirements, safety parameter values, navigation watch levels, and more. It also includes data collection, UKC formulas, overhead clearances, and the print settings that support the finished documentation. Once these defaults are in place, route-specific adjustments become much faster and more reliable. Returning to the Lisbon to Gibraltar route, we can now adjust the passage type so the plan matches company SMS requirements. Instead of changing each waypoint one by one, we can apply passage types across a selected waypoint range, which is much more efficient. If needed, we can also reset the defaults for the coastal sections and then apply the company standard again where it belongs. This keeps the route aligned with both navigation practice and internal compliance expectations. We can also refine the route at waypoint level. For example, a berth waypoint can be renamed so it reflects the operation more clearly. At the same level, we can adjust cross-track limits and the turning radius to suit the maneuvering requirements of the vessel. We can then add position references and create a parallel indexing line, which gives the bridge team more useful monitoring information during execution. These edits are small, but they strengthen the practical value of the finished passage plan. The next step is to add action points where we want the bridge team to carry out a specific task or record an operational milestone. We can also mark passage type events such as commencement of sea passage and end of sea passage, so the route reflects the voyage phases clearly. With those elements in place, the route is ready for the validation stage. Now we can run a route check and review any geo-referenced alerts that the system identifies along the route. Issues can be reviewed leg by leg, which makes it easier to understand exactly where attention is needed and what should be corrected. We can also print the route check report, and the validation remains dynamic because the checks update as we adjust the waypoints. Once the route has been validated, we can create the passage plan directly from it and move into the voyage-specific planning details. Here we enter stability information, draft values, and any other voyage parameters needed to support the plan. A lot of voyage data is then populated automatically, including port details, tides, and restrictions, while operational notes can still be added manually where needed. That gives us a passage plan that is both efficient to produce and still flexible enough for vessel-specific requirements. The generated passage plan already organizes a wide range of information for the voyage, starting with departure and arrival details, general notes, and contingency planning. It also includes voyage leg specifications, navtex information, radio calling in points, the UKC overview, and any action points we have added. Beyond that, the document covers charter party notes, environmental and security information, plus navigation and scheduling data. Watch levels are also included, giving the bridge team a more complete operational picture for the voyage. Taken together, these sections help turn a validated route into a usable working plan for onboard execution. The remaining sections go even deeper into the safety and documentation side of the passage plan. These pages include the initial and full UKC calculations, along with chart portrayal settings and other safety parameters used in the plan. They also capture position references, parallel indexing, leg safety parameters, and voyage remarks, followed by publications, ENC data notices and warnings. Finally, we have signatures, squat figures, and the full UKC tables which complete the record for review and approval. Looking at a completed example for the same voyage, we can immediately see how the plan brings user input and system-generated content together. Here we can see a completed passage plan for a quick review. The user has entered calling in points for radio communication, additional departure point information, and outbound passage notes here. This is the arrival port information page, similar to the departure page. There are additional requirements from the charter party and master. General Notes Part 2. It includes environmental regulation information and security-related remarks. Scheduling information is also provided. Part B includes details on under-keel clearance. Part C covers landmark bearings and parallel index information, as previously discussed. Part D contains leg safety parameters and user remarks. Here is information on the database update status and resources used for creating this passage plan. Any additional paper charts will be listed here as well. Details of any revisions and additional notes are included here. Voyage squat figures page. And finally, the full under-keel clearance calculations pages. This is where the workflow really comes together, from route generation all the way to a complete operational plan. As we've seen, autorouting and NavStation can support safer, more efficient, and more compliant route and voyage planning across the full workflow. Even so, the final route must always be reviewed and validated by the navigator before use. Thank you for joining the webinar. I hope this demonstration has been useful, and we are happy to take your questions.